अब पहले से आराम है। पहले से आराम है।
Is Ahmed, can you hear me? Can you hear me?
Yes, Ahmed, yes.
I'm waiting for Engineer Ahmed الحديدي.
Ahmed, now your voice is not clear.
Welcome to the 128th free webinar by OBA, presented to you by Engineer Ahmed Al-Hadidi. Engineer Ahmed Al-Hadidi is a petroleum engineer with more than 13 years of experience in well stimulation and intervention in the Egyptian oil and gas sector, currently serving as a team leader for well simulation and a member of the well intervention team at Khalda Petroleum Company. Engineer Ahmed Al-Hadidi has authored research papers on applying machine learning in well operation, matrix acidizing, and hydraulic to improve production use all. Engineer Ahmed, we are happy to have you with us today. Hope everyone enjoys today's webinar. Engineer Ahmed, the mic.
Engineer Ahmed?
Yes, so do you hear me now? Good.
Yes, we can hear you, Engineer.
Thank you. So just I will share my screen. So is the screen is clear for all?
Yes, engineer, yes.
Okay, so welcome for this session, this webinar with OPA. So I would thank you for your timing, and I hope you get a productive time and you get a new informations or a knowledge that we can exchange for today. So we have almost, inshallah, for 40 to 50 minutes the webinar, and then we are going to stop. And anyone have a question, it's more than welcome. You can write your question in the chat. And after finishing the session, we can start to check the question and answer, inshallah. So we are going for today, we'll try for what we have from time to get an introduction for the meaning of the formation damage uh, and how we can remove this damage or how we can cure. First, how we can mitigate this damage, and if it's done and already we have it in our reservoir, how we can remove it and restore our productivity or injectivity. This is based on the status for our well as a producer or injector. So as you know, the formation damage, it's a terminology referring to the impairment for the permeability for the reservoir. And we can represent this damage by the skin effect or the skin value. And as you know also, when the skin is positive, it indicates that we have a damage in the reservoir based on the value for the skin as positive 2, 4, and 6, and so on. So, and 0 is almost that we don't have a damage, it's a neutral. And with minus skin, it indicates that we have a fractures inside the reservoir, or we have done with stimulation, whatever the type of the stimulation, could be hydraulic fracturing, could be matrix acidizing, or even any chemical treatment. And we can define or predict or measure the skin value by the well testing. Is we can conduct a flowing pressure buildup testing. We have a good flowing time, then we conduct a shut-in time to get or to reach the boundary condition as a radial flow to measure from the analysis the actual value for the skin. And from this value, we can plan how we can remove this damage, or if this well, it needs or not a stimulation. So the critical point, or what we need to highlight it here, so before you conduct any operation, even as a recompletion or remedial work or a well intervention as a well stimulation, you should define your type of damage, your formation damage, to select your optimum solution or optimum treatment to solve what you have. Because if you fail to succeed, if you fail to define your problem or what type of your formation damage, you will select improper treatment and you will cause more damage than what you have. So, and also you will pay more cost to solve your problem. So you will pay more cost, you will take more time, and you can finally lose actually your will that you already increase your damage. So the first point, or what you should take in your mind, that we need to define what we have, what's the cause of the damage inside our reservoir. So mainly, if we can classify the types of damage, we have could be mechanical mechanism or biological mechanism or chemical mechanism or thermal mechanism. These are four category for the reasons behind the formation damage. So if we can talk about shortly about each classification, we started with the mechanical mechanism. One of the most common mechanisms, the fine migration. This fine migration could occur while the production. So once you start the production in your well and your reservoir is unconsolidated sandstone, for example, so you expect that you have something like sand production or fine migration from the mineral itself. So it will ending by this fine migration. These fine particles will move. We are going to move with the flow inside the well pore, can cause a plugging for the pore throats inside the reservoir itself, or even it can make a filling inside your well pore, make a full plugging to the reservoir, prevent the flow to get from inside the reservoir to the surface because you have a fill now inside your reservoir due to fine particles. Also, if you have a clay's particles, once the flow start to move, start to break down these particles, and also it will move through the flow, plug the porous throats, decrease your porosity, then decrease your productivity. Another example when it's the mud solids. If you used a killing fluid with no filtration, not filtrated fluid, it could be have some solids particle as impurities that when you pump it inside your reservoir as a killing fluid, if you're pumping as a pole heading, if you make a reverse out as a circulation inside your reservoir, these particles will precipitate inside your reservoir, or if you have a good reservoir properties, high porosity, high permeability, so we have a high probability these solids will be invaded inside your reservoir, plugs your porous throats, and cause severe damage. Also, the perforation itself, it can cause a damage because the perforation, it depends on explosive material, and this explosive material, when subjected to the formation, make something called crushed zone around your perforated tunnel. Other example is the geomechanical induced. So how the deposition environment affected your lithology if you have high stresses inside your reservoir or subjected to your reservoir. So you will face almost something called high frag gradient. So you will not able to exceed this frag gradient and you will not frag your formation. Also, it will affect the injectivity index itself. So if this an injector well, so will predict that you will have a low injection rate in your well. If you have a low stresses, that means that you don't have a good stresses as a confined area for your reservoir lithology. So you can expect that you will have or you are going to face a problem from sand production or fine migration. Also, for example, another example is the chemical mechanism. And this is very, very clear example and very common example because the chemical mechanism, one of the most common example here is the rock fluid interaction. So when we can step back one step, in the petroleum industry, there is something called the compatibility. This is a very critical item. You should confirm your compatibility between the fluid that you are going to be used as a killing fluid, as a drilling fluid, as a stimulation fluid, this compatibility between this fluid and the fluid inside your reservoir. So this is a compatibility between two fluid, between the fluid that you will be injected inside your reservoir or will be used inside your reservoir and the fluid itself of the reservoir, the reservoir fluid. Because if these two fluids are not compatible, it will make a damage inside your reservoir. It can cause emulsion, and the same idea, when we have an emulsion, the emulsion will plug your porous roads, will decrease the capillary pressure, and will affect your productivity. The another type of the compatibility is between the rock and the fluid itself. Because while you're moving or while the drawdown, for example, for a producer well, while the drawdown, you affect with shearing force of the fluid on the rock itself. This shearing can cause a fine migration, or the particle itself, it will break apart, will move through the flow, plug your reservoir. It could also plug your well bore, or even can cause problem on the surface facility as a pipeline or a separator and the tanks, all of this. So the fluid incompatibility can cause emulsion, solids as a hydrate, as a scale, as a precipitation. Also, if the oil itself has an issue, can cause a paraffinic and asphaltenic problem. Also, the thermal mechanism, it's one of the main items that can cause damage if we have a high reservoir temperature and we have a clay's content. So usually this clay content are very sensitive, become very sensitive to any flow. So can cause damage from clay swelling or fine migration. Also, any fluid, if it's not compatible for specific reservoir minerals at specific pressure and temperature, can cause wettability change. And once if it changed from water wet to oil wet, your reservoir or your production will become watered out. You will produce only water, or the oil percentage in your production will be decreased. So almost we have also the last one, if we can talk about, is the biological mechanism, and it's clear by the corrosion. So if you have a tubing, a production tubing or completion tubing, it's not clean, it's an old string, or if your well has a sour environment as producing oil or gas with high H2S or CO2, so it can cause a corrosion in your tubing. So rather than what that will have an integrity issue in your tubing and in casing environment, also this corrosion will precipitate inside the well bore and inside your reservoir and cause plugging and affect the porosity and the productivity. So as we mentioned when we start the session, it's very important to define the definition, or to define what is your formation damage that you have inside your reservoir. And after you define your formation damage mechanism, you need to investigate or predict the place for your damage. If it's near your reservoir, it's inside your well bore, it's far away on the matrix itself, to confirm or to predict the place for your damage. So, for example, if you suffer from wettability issue, so you make sure that this wettability inside your reservoir. So you need to select optimum or treatment chemical to restore your wettability. It change. Also, if you have a water blockage, it will be inside your reservoir. But if you have a scale, so we can predict, or you confirm it, that this scale can be inside the tubing, on the surface or bottom hole, inside your sand screen, inside your perforation tunnel, or inside the pore throat itself, inside your formation. So it's very important to define first your damage, second to predict or to confirm where is your damage, to select the optimum treatment, and optimum operation to avoid additional cost to restore your production or injection. So when we start our session, we talked about skin effect and we talked about how we can measure the skin from the well testing, but also, as all of you know, that the nodal analysis, it give us also a figure for the skin by select your node and put your pressure system, and you can match your testing and estimate the skin value based on your permeability and reservoir rate, pressure, and so on. So also there is a term is very interesting, is called a pseudo damage. It's not a damage, it's not an actual damage due to the reservoir. It's a damage related to mechanical issue. Could be a restriction in your well completion, could be bad design on your surface equipment, bad design in your completion. If you have a collapse in your tubing, if you have a bad design in your perforation, if you have a bad drilling section inside your reservoir, if you have a laminated reservoir, if you have an uneconomic or limited reservoir. So all of this, we have a several options or several probability that can cause what we call a pseudo damage. So this damage is not a direct damage due to scale or fine migration or minerals problem. It's a damage related to mechanical issue or to well or reservoir properties itself. So here, most of the options that we have, we cannot proceed with treatment as a chemical, as a hydraulic fracturing or as acid treatment. So we need to change our thoughts or change our strategy to deal on what we have called a pseudo damage. So from what we mentioned, it's better to avoid the damage actually to become a problem than to try to restore it, because to try to restore your damage, you will pay too much money, you will drop or you will lose a production or injection, and the success ratio is based on your treatment, your damage, and your operational efficiency. So let's take an example, some photos for what we are talked about. So this photo for a reservoir, and we have a fine migration. So you can observe that so if you see my pointer, when we have a shearing forces exerted or affected or subjected to the particles, this particle based on the mineral itself, because not all the minerals when subjected to shearing can cause damage. So we have specific minerals that cause this problem. So once this type of mineral subjected to shearing force or drawdown, high drawdown, this fine particle will start to break apart, start moving through the flow, cause plugging in your porous roads. And when you start production or when you want to resume production, it will fail, or you'll suffer from drop in the productivity until your well cease to flow or stop to flow, because these particles are plugged, have been plugged your porosity path, or what we call as your pore throats. Also, if you have a compatibility issue, or if you have an oil that characterized by paraffinic content, so you can observe the problem when you retrieve your production tubing or when you have a tubing on your rig site. you can observe how much or how the plugging affect your production area. That's why your production on the surface is decreased, because not inside your reservoir, because your tubing or production tubing has almost completely filled by paraffin or asphaltenic content. So you need, when you define this problem, to select a good treatment, the optimum treatment to actually first to solve your problem here. Then you need to think or find the solution to prevent or to mitigate this damage from the beginning, to avoid additional cost to clean your tubing or for work over. Also the asphaltenic, and if you know the difference, the asphaltenic, it's more heavy component as a C plus in the aromatic chemical. So it's more viscous, it's more heavy, cause plugging almost completely for what you have as a mechanical equipment. So if you see in this image, this is a stage and impeller for the ESP. It's an artificial lift technique. So you can observe the almost the clearance of the impeller itself is full plugged by the asphaltening. That's why we lost the production from this weld. Plus, in this, it's not, as when you talked about this problem, it's not just we lose a production. Actually, we lose a completion, because this will suffer from failure, because this plugging cause plugging for the shaft, prevent the shaft to rotate, and once the shaft not able to be rotated, it will be break down. So I lose my weld, I lose my production, and actually I lose my completion or artificial lift string that I needed in the next time to pay additional cost for the string as a completion, as artificial lift, and to solve the problem. So also there's an actual photo for a scale. It's called barium sulfate, if you hear about it before. So this is one of the most dangerous scale that exists in the petroleum industry. It causes a severe plugging, a full plugging for your tubing or inside your reservoir. And the issue for this type of scale that sometimes in some conditions has a norm effect, so you will not be able to deal with it. And also one of its problem that it's not easy to dissolve in chemical or in chemical treatment. So you need to consider or take some considerations to select the optimum way to remove this type of scale. So the problem of the scale, as you see, it's a solid particles, very solid, cause complete plugging, especially inside your reservoir. It will damage your reservoir completely. And in some cases, the final result for this such type of scale end up that you can leave your well and drill new well away from this problem. You can make a TA, side track, and what's on the problem. Also the same issue, but zooming for the asphaltenic deposition and the paraffin deposition, it's comparison, and that you can see that the asphaltenic component are more viscous than the paraffin deposits. Also this a common issue or common problem for the production tubing or the drill pipe is the iron scale. So if you have an iron scale, while the production, while the injection, while the drilling, this scale are precipitated or breakdown, either precipitated inside your reservoir, inside the reservoir and the well bore, and cause a full plugging into the wellbore itself or inside the reservoir, or can be migrated and flow upward to the surface, causing a problem in the surface facility, as we mentioned, in the separator, in the tank, and so on. So from all of this, we can conclude that the very important point that we need to define the type of the damage and its location, confirm this is actual damage, it's not a pseudo skin. And after of all of this, after we confirm the type of damage and if we are going to remove it by well stimulation, so we need to understand what is the well stimulation. So the well stimulation, in simple way, we can classify it to inside the formation or inside the well pool. So if we have a plugging or scaling inside the well pool, we need to remove this scale. We can remove it by chemical treatment, we can remove it by drilling, we can remove it by milling, and so on. Or even we can pump some chemical and use a mechanical solution as a milling together to restore the productivity or restore your well pool integrity. The other one for the formation, and this is a common one. And we need to precise if we are going to frac or we are going to pump a chemical. When we are talking about a fracturing, that means that we apply pressure exceeding the frac gradient for the formation. And when we are talking about a chemical treatment, that means that we pump the chemical below the frac gradient or the frac pressure for the formation to avoid breaking down the formation. And for the matrix acidizing, it could be for sandstone or for carbonate. For the sandstone, it's more complicated. We have a very high probability for damage while conducting acid stimulation. So it's very important to consider several precautions while selecting the treatment, the type of fluid, the type of acid, while the sandstone acidizing to avoid this damage. Because if you have a damage and you select improper design, improper fluid, you will increase your damage and you will increase your skin value. And this example for specific type of minerals on the left side is the image for this minerals before the matrix acidizing, and on the right side you can observe the pathway or the new pathway or the new conductive base that generated or created by after applying acidizing or matrix acidizing for sandstone. And at the last, or the another type of the acidizing, is the carbonate acidizing. And it's mainly by HCl or by organic acid. And you can observe this is more easy, less risk than the sandstone. We create wormhole as you see in the image. We can create a wormhole. Once we create the wormhole, so the acid is dissolved, that's the scale, is dissolved the mineral itself, create a huge wormholes, connect the natural fractures together, and enhance and increase your production or your injection. This is based on your status for your well. So when we compare the carbonate acidizing with the matrix acidizing, the carbonate is less risk. But anyway, when we are going to treat with acid chemical or acid treatment, we need to take all the safety precautions because has, of course, as you know, has a damage effect for the equipment, for the completion, and also for the reservoir, and the important one on the human itself. So we need to consider all the safety precautions when we are going to deal with a corrosive or with acidic fluid. Another technique is the hydraulic fracturing. This is another story that we are pumping our frac or our fluid with pressure exceeding the frac pressure to create a fracturing geometry to bypass the damage, to enhance the conductive path, and finally it translated as high productivity index and low skin effect. And here you can observe when or what the acid as HCl affected on your carbonate reservoir. You can observe this huge pathway for the created path by the HCl. Also, you can observe here for this is a core scan. We are talking a several core for horizontal or for vertical section. We can observe this core have heterogeneity as a different in the permeability. And you can observe, or when we are dealing with subject like this, we are using something called diverter to enhance or to confirm that your fluid or chemical treatment are distributed along all your reservoir to confirm that you removed your damage as a scale or as a particles to the dissolved for all your section inside the reservoir, not only the good permeable or the good porous medium. So there is something called diverter we are used to confirm the distribution, the homogeneity distribution for our fluid. So that's all for today. I hope that you get a new info and it's welcome for your question.
Thank you, engineer. All was clear.
Okay, thank you, Fatima. Anyone have any question? Okay, so I would thank you for your time and for your listening. And I hope you all the good in your future, inshallah. Thank you.
Thank you, engineer Ahmed. Thank you for your time.